Hi and welcome back. This is part 2 of basic differentiation rules and rates of change. Okay, and so we just finished up with the constant and multiple rule. In other words, when you have a constant, you multiply it by the differentiable portion. Okay, now is the sum and difference rule, and basically the sum and difference rule is that you can add or subtract derivatives as you go. Okay, so that one's pretty simple. So something like this, let's say we had f of x is equal to x to the fourth minus 2x to the third plus 5x to the second minus 4x plus 7. Okay, now you do when you do sit down with this, that stupid 0, it's supposed to be in closed parentheses. There we go. Alright, when you do sit down with this, if you get into it and you really think about it, you want to think about this as g of x, the second one is h of x, this one as m of x. We don't use I because that's imaginary. Just don't want to cross that road. N of x. And this one as A, B, C, D, M, N, O, P, P of x. Let's go P of x. There we go. Okay, so you want to think of this as not just one function, which is just f of x. You want to think it as the sum and addition of several functions, which is g of x, h of x, m of x, n of x, and p of x. Because when you do it this way, when you get to actual quotient rule of differentiation, it will start to make sense. But anyways, we would just do the derivative, the basic power rule here. This would become, okay, so f prime of x is going to be equal to 4x cubed. Alright, the next one is going to be the h of x, which is going to be the negative 6x squared. The next one is m of x, so this is going to become 10x to the first, or positive plus 10x to the first. Okay, and I'm not going to write 10 to the first. The next one is n of x, which is just going to be minus 4. And then the next one is a constant, so that turns into 0. Okay, and so everything's simplified here. Obviously, you would just use this part for the beginning. Okay? Alright, now derivative of sine and cosine. This is going to be a lot of fun because this is going to be some easy stuff. Okay, so the derivative d dx, and I'm going to start using this term of sine of x, and this is the one made famous by Leibniz. Okay, is going to be cosine of x. Okay, and d dx of cosine of x is going to be equal to negative sine of x. And this is one you are going to have to memorize because you aren't going to have these rules available to you when you take the AP test. Okay, so how do we do this? F of x is equal to x to the third plus 2 times sine of x. Okay, so the first part's pretty easy. We're going to have f prime of x is equal to 3x squared. That's our power rule. And then this is going to be plus 2, and then you're going to times it by the derivative of sine is going to turn into cosine. So this is going to be cosine of x. So that's pretty simple. It's pretty straightforward that you just bring it down, and it is an addition. It is a sum rule. Okay. All right, now when you do use cosine, when you do derivative of cosine, you do need to take into fact that it does have a negative in front. So you are going to be changing signs with that, okay? All right, and I do want to go over some more. So basic. Okay, just reminding myself of all the derivatives. Oh, come on. Where is it? There we go. All right, now there are some that you do need to know right off the bat, and I'll just bring it over. Okay, and this is from mathisfun.com. Really great website that just gives you great examples. Okay, so derivative of constant we've covered. It's just 0. Derivative of x is just going to be 1. Okay, derivative of square, which is just the power rule, is going to be 2x. All right, square root, this is x to the 1/2. So that makes sense why it's 1/2 times x to the negative 1/2. All right, now exponential, here's a cool thing. E to the x, the derivative of e to the x is e to the x. It's the same thing as is. And it's really interesting how it works that way. Now, if you have any other number to the x power and you're doing the derivative with respect to x, or d dx, d over dx, okay, you're going to use that same thing, but times it by the natural log of a. Okay, logarithms, the derivative of the natural logarithm is going to be 1 over x. Okay, the derivative of log base a of x is going to be 1 over x times the natural log of a. Or not natural log times a, it's going to be the natural log of a. Okay, trig, sine is going to be cosine. Cosine is going to be a negative sign. Tangent is going to be secant squared x. Sine inverse is going to be 1 over the square root of 1 minus x squared. Tangent is going to be, tangent inverse is going to be 1 over 1 plus x squared. Okay, so we just talked about these ones first off. Okay, product rule we will talk about at a later time. But here's an interesting fact. If you take 2 of them and you times them together, okay, and you're trying to find the derivative of that, and I'll show you later what it is, you take the derivative of the second, times it by the first, and then you add it with the derivative of the first times the second. Okay, and really interesting, the quotient rule is a lot like what we just did, except it's the derivative of the first times the second function minus the derivative of the second function times the first, all divided by the second function squared. Alright, the reciprocal rule is going to be 1 over f, or 1 over the function. It's going to be the negative of the derivative of the function divided by the function squared. Okay, and then chain rule is a huge one we'll learn later. I don't expect you to know that right now. Okay. So, some pretty easy stuff right there. It is easy when you do take your time and you practice it and you understand where it comes from. All of this stuff comes from the difference quotient, and that's huge that we understand that, okay? Alright, so if there isn't any questions, I will talk to you guys later.